Hey Professor, this is Rob Hines and this is my solution for the homework 6 assignment.
Okay, so for problem one, part one, they asked us to use piecewise linear interpolation to determine y for x equals 0 as y as x equals 1. Then part two asked us to use quadratic interpolation to determine y for x equals 0 and then as well for x equals 1. Okay, so here I have my response to part one, which is right here. Need to clean this lens. And then this is my response to part two right here. Alright, this is my code that I used for interpolation. It's easier to see on my iPad, so I'm going to go ahead and explain the code on my iPad really quick. Okay, so I'm going to explain this section by section like I usually do. That's fine. Okay, so right here, this section, what we have is we have the, these are our data points. These are the data points we use for the piecewise linear interpolation as well as the quadratic interpolation. For this segment here, wait, is that the right? Yes, yeah. Okay, so for this section here, what this part does is it just executes, the linear interpolation. Then, crap. These parts here, so the first part is the interpolated value of y at x equals 0, and this is the interpolated value of, okay, this segment right here, we have, so this is the n degree polynomial for the data points. We have n is equal to 2, and then what p does right here is it actually stores the coefficients that we get from the quadratic polynomial. Yeah, what polyval does, the polyval function, is it calculates the quadratic polynomial, and then we have these here. This is the first one. This is the quadratic interpolated from x equals 0, and this is the quadratic interpolated at x equals 1. This whole segment right here, basically what the fprintf does is it just prints the computed values, and it does it to 4 decimal places as we specify right here. The results for, like, the answers we get for both of the interpolation methods that the problem asks us to do, those will be displayed in the MATLAB command window. Okay, what this line does right here, linspace gives us, as we see, we specify with the 100 value here. This gives us 100. This gives us 100 equally spaced x values, and then it does it between negative 0.2 and 2.1. This should give us a curve for our interpolation that we're doing. Okay, then we have this segment right here. This first y linear, this gives us, or it stores the linearly interpolated numbers, and then this one stores the quadratic interpolation values. Alright, so this is a lot, but I'm going to try to go ahead and explain as quickly as possible. So basically what our figure here does, that is a really bad arrow. Figure gives us a new plot window. Hold on, make sure that multiple plots are drawn within the same figure, if you will. Okay, this RO, this gives us red circles for our original data points. Marker size, sheesh. Okay, this changes the marker size, makes it a little bit bigger. Where is it at? Yeah, then the display name, this gives us the, this labels the data points for the legend that we have in our plot that this will create. Then we have the B dash here. It's going to give us a blue dash line for the linear interpolation. The G, the dash, basically what this does is it ensures that the quadratic interpolation is represented by a green solid line. Then we have this BS and a GS. The BS does not stand for an expletive, but the BS is basically short for blue squares, and the blue squares are going to represent linear interpolation points. Then the GS, green squares, are going to represent quadratic interpolation points. So that's that segment. And then finally, this segment here, you have the X label, which just labels x-axis, y-axis. Legend displays a legend, obviously. The grid creates a grid for the plot. This is our title. This is our title for the graph. And then hold off stops plotting the figure. And that is the long and short of all of our code. Next, I'm going to go ahead and explain the actual graph here. So in our code, I already explained a lot of what everything stands for. But as you can see in the legend, it just gives you exactly what each character or symbol, what it is. But in addition to the legend, which is pretty obvious and self-explanatory, I'm going to go ahead and summarize what the graph is actually telling us. So linear interpolation, which is characterized by the dashed line, it's pretty simple, but this is not really what we want. This is not really giving us a curve. Then the quadratic interpolation gives us a curve, and it shows us a lower minimum here. So that's a little bit better to helps us visualize what we're doing a little bit better. And then, as we can see, the quadratic curve is a lot different from the linear interpolation. It's just a lot different, but basically the interpolated values at x equals 0 and x equals 1 are going to be a lot different between the two methods. So that should cover the entirety of this homework. Yep, and that is it for homework 6.